Now let's go ahead and write the C++ logic for finding the nth root of a number. So here, as part of the problem description, we will be given the value of n and m. We need to find a number such that if we perform that number power n, it should basically yield the result that we have gotten in the variable m. So that is the solution that we need to write, right? To solve the solution, what we will do, we will take the help of the binary search. So whenever we implement any solution with binary searching, what we'll have the left value and we have the right value, and we will try to find the middle, and based on some condition we will either continue the search in the remaining half of the search range. So here, first let me just go ahead and initialize the left. This will be initialized with 1 in the beginning. Similarly, what I want to do is I want to initialize the right. This will be pointing to the value of the m in the beginning. Similarly, what I want to do is I want to initialize one variable called middle, and this I want to initialize it with -1. Now all we will do is, as long as this left is less than or equal to the value we have in the right, what we will do, we will calculate the middle. Middle is nothing but left plus right divided by 2. Once we have this, what we will do, we will basically try to calculate middle power n. If that is equal to m, that middle itself is the root of the number and we can return that. So for calculating the power, here I will be using the math library. So let me just import the math.h. Once we have that here, what we want to do, we can call the power function. This we will pass the middle, and then we will pass the value of the n. And let's just store this value in some variable called result. Okay, let me just correct the name. Once we have this result, what we need to do, if at all this result is equal to the m value that we have gotten, this result itself is the nth root of the number, so we can return that. So we can directly return the middle. Okay, if this is not the case, if at all the result that we have gotten is greater than whatever the value we have got in the m, that means we need to find the appropriate value in the left part of the search range. That means from left till middle -1. So we will basically update the right to middle -1. So we will update right equal to middle -1. If this is not the case, obviously the other scenario would be, we need to search the value in the right part of the search range, where we will update the left to middle +1, so that this logic will keep on going. So here, let me just update the left to middle +1. Okay, in that way we are basically trying to find the nth root of a number using the binary searching algorithm. Very simple implementation. We have defined the left from 1 till m, whatever the m value that we have given. In that, if at all, as long as the left is less than or equal to right, we tried finding the middle and used that for calculating the power. And if that result is matching with the value of m, that middle itself is the value. Otherwise, based on the nature of the result that we have gotten, we are restricting the search to either left part or to the right part. Okay, now let's just go ahead and test this out, right? Here the value of n I have passed is 4 and the value of m I have passed is 81. So if I run this, 3 power 4 is 81, right? Because 3 into 3 is 9, 9 into 3 is 27, 27 into 3 is 81. So if I run this code, I should be getting 3 as output, and 3 is what we have gotten on the console. For example, here let's just assume I have given 3 and I have given 8. So if I do 2 power 3, I should get 8, right? So if I run this code right now, the output that I've gotten is 2. For example, let's just say here I have passed 9. That means that, there is no number to which if we perform cube, we will basically get the value 9, right? So we should be getting -1. So here if we see, -1 is what we have gotten. Here, if at all, if we don't find any result while executing this while block, in the end we are returning -1, right? Indicating that there is no nth root for the values that you have passed. Similarly, you can pass anything. Let's just say I have passed 2 and here I have passed 225. I know that 15 square is 225, so I should be getting 15 as the output. So if I run this, see the output that I've gotten is 15. Okay, similarly you can pass any number of values in n and m. Based on the nature of the values that you passed, you will basically get either the absolute nth square root of a number, nth root of a number, or -1 as output. Okay, that's about the effective implementation of finding the nth root of a given number.